Hey guys, in this video I'm going to walk you through how to solve every single question in paper 2, the reasoning paper in the 2023 Maths Sats. Okay, let's get started. Question 1, circle the clock that shows 5 minutes past 11. So 5 minutes, 11 is the hour. So this skill is not going to be taught in year 6. This will be a year 3 skill. So if you're not sure on telling the time, there are lots of resources online, but you do need to know how to read the time on an analog clock. Even though you're in year 6, you're tested on stuff that comes right back from the year 3 curriculum. So if this is something you missed out in school, then go and find, there's plenty of resources on the internet. I will try and link in the video notes to some resources where you can learn how to read the time on an analog clock. So minutes, let's do this in different colours. Minutes I'll do in pink. Hour I'll do in green. So 5 minutes is this part of the clock. So if we look, the minute hand is the longer hand. So we can see the 2 at the bottom. It can't be those because the minute hands are not on 5 minutes past. So we can eliminate those. So both those top 2 clocks have got 5 minutes past. And then 11, the green is this, 11. So you can see that this second clock here, we've got 11 o'clock with the hour and we've got 5 minutes with the minutes. The first one, the hour hand is actually pointing to 2. So this one's actually showing 5 past 2. So it is in fact this clock, 5 past 11. Question 2, write these temperatures in order starting with the lowest. You will see we have some numbers that are negative numbers here. This is a year 6 skill. If you're not too sure on negative numbers, then a lesson can be found on this in my number, place, value, SATs ebook. I go through all about how to order negative numbers and how to calculate with negative numbers as well. So starting with the lowest number. Now, negative numbers are opposite to positive numbers in that a minus 10 is smaller than a minus 4. Okay, so the bigger the number, the smaller it is when it has a minus symbol next to it. And it's very important that we do take note of what it's asking us to start with, the lowest. Okay, so the lowest one, if we look, we've got 2 negative numbers. Negative numbers are smaller than positive numbers. Minus 10 is the smallest. Minus 10 is smaller than minus 4. Okay, so minus 10 is smaller than a minus 4. And then we can simply order the other numbers as we would normally. So we know that 1 is smaller than 3 and is smaller than 6. So there we go. Question 3, ABC is a triangle. What are the coordinates of point C? So here's our triangle. It's called A, B, C. Those are the vertices on our triangle. What are the coordinates of point C? So it wants to know what this coordinate is here, what this coordinate is here. So we're simply going to read along our coordinate line. Now, if you're not too sure on coordinates, there is a lesson, there are lessons on coordinates in my SATs and geometry ebook, which is in the position part of the geometry ebook. It's also part of the Year 6 National Curriculum. Now we go across the x-axis first, we go along to 6. So it's 6 on the x-axis. And then we go up and it is 2 on the y-axis. So the coordinates are 6, 2. 6 along the x-axis and then 2 up the y-axis. Question 4. Some children choose their favourite zoo animal. The pictogram shows the results. Now we have a key here, so we need to pay attention to the key. The key says that a circle stands for 2 children. We have our animals down here, penguin, elephant, tiger, giraffe. And here it says number of children with circles in them and semicircles. Remember, the key is that each circle stands for 2 children. How many more children choose tiger than elephant? Now, this is the bit that's important because this is the bit where people go wrong. How many more children choose tiger than elephant? So we're looking for the difference between the tiger and the elephant. Okay, if we look at the tiger and the elephant, there's a couple of different ways you can do this. We could either label elephant. So remember, each circle is 2. So 2, 4, half of a circle will be 1. So this is 5. And tigers, 2, 4, 6, 8, 10, 12. So we can see there's 12 tigers, 5 elephants. How many more tigers are there? How many more children chose tiger than elephant? Well, 12 subtract 5, or the difference between 12 and 5 is 7. So our answer is 7. Another way you could have done this is to draw a line like this. And anything past that line is how many more there were. So we've got 2, 4, 6, and 1 is 7. There were 7 more children that chose tiger than elephant. Both ways get you the right answer of 7. Question 5. Cars and motorbikes are parked in a street. We've got a car with 4 wheels and a motorbike with 2 wheels. Stefan counts 3 motorbikes and 5 cars. He counts 28 wheels altogether. Explain why Stefan cannot be correct. So we are explaining why he is wrong. So let's test his theory. He's saying there are 3 motorbikes and motorbikes have 2 wheels. So we need to do 3 times 2. And he's saying there are 5 cars. So 5 cars times 4 wheels is 5 times 4. So that's what he's saying he's seen. Let's solve each of those. 3 times 2 is 6. And 5 times 4 is 20. And 20 plus 6 makes 26, doesn't it? So that's why he's wrong. So we might say something like 3 motorbikes have 6 wheels and 5 cars have 20 wheels. 6 plus 20 equals 26, so he cannot be correct. Even just writing the calculations there on the screen is all going to be part of your explanation. Question 6. Kirsty buys 1 litre of apple juice for £1.39. She pays with a £5 note. How much change does Kirsty get? This is a 1-mark question. It is just one simple calculation. We need to know that she paid £1.39 and that she paid with a £5 note. How much change does she get? This means we're doing a subtraction. It's a very simple subtraction. However, what you need to be mindful of is when you write your £5 that you make sure that you put in your 0 pence, because we are subtracting £1.39. This is the most common error where we don't put the zeros in for the 5. And what I've commonly seen is 0 take away 9 is 9 and 0 take away 3 is 3. That is not correct, okay? But that is what is commonly seen as this is a common error, basically. So make sure you put your zeros in and make sure that we're remembering that we can't do 0 take away 9. We're going to have to go over to our 5 and we're going to have to do some exchanging. Okay. If you are unsure how to subtract like this, then you need to check out my SATs ebook, the number calculation ebook. Either that, or you can also have a look at my Arithmetic Academy short course for SATs revision. That also goes through how to add, subtract, multiply, divide, just the common calculations. Okay, so we can just start to calculate now. 10 take away 9 is 1, 9 take away 3 is 6, and 4 take away 1 is 3, not forgetting the decimal point. So our answer is £3.61. It's very important that you do put the decimal point in, and that if you were calculating in pennies, for example, so if you decided to do 500 pennies, take away 139 pennies, and then you got your answer 361 pennies, that you wrote your answer in how it's asking you to in the answer box. It's got the pound sign there, so you must write it using pounds. So don't forget to put your decimal point in here. Question 7. Here is a number sequence. Write the next 2 numbers in the sequence. So when we're looking at sequences, we're always looking to see if there is a pattern. The first thing that I notice is that my number is going down, it's decreasing. So I know it's going to be a subtract. Okay, next thing I want to do is figure out what the difference is between the first 2 numbers in the sequence. Now I can do this in my head, and some of you may be able to. If you can't, just subtract them very quickly to find out what the difference is. So 5 take away 0 is 5, 7 take away 5 is 2. So that is subtract 25. And then just double check if the same applies for the next one. So we could do 50 take away 25, and we'll just check if there is a pattern. So 10 take away 5 is 5, 4 take away 2 is 2. So we have found the sequence at the pattern. It's take away 25. That means we need to carry on taking 25 away to get the next 2 numbers. Okay, so 25 subtract 25. And just rub this out so that I can just do a number line. So we have gone like this. $75, $50, $25, and then we want to know what this number is and this number is. Each time we've taken away 25, so what would be this number if we took another 25 away? Well, it's 0. Okay, 25 take away 25 is 0, right? If we're on 0 and we take away 25, we're going to get to minus 25. Minus 25. If you are unsure how to subtract once you get past 0, once you get smaller than 0, then you need to check out my number, place, value SATs ebook, where there is a lesson there on negative numbers, on ordering them, and also how to calculate intervals past 0. That is a specific learning objective in the Year 6 National Curriculum. Question 8. In 2012, there were 24,372 schools in the United Kingdom. Round the number of schools to the nearest 100. Okay, so when we are rounding, we are told what we're rounding it to. What I would do is write out my number, label the values, so ones, tens, hundreds, thousands, and 10,000s. We're rounding it to the nearest 100, so I would look at my digit that is worth 100, and what I need to do is write my number out where these are going to be zeros. Okay, so if I look at the 100 digit, I look at the one directly after it, which is a 7. If it's 5 or greater, my 100 number is going to go up to the next one. If it's 4 or less, it's going to stay as a 3. So I can see that it's a 7, so that is 5 or greater. So my 100 number, my 3, needs to round up to the next digit. So this needs to round up to a 4, and then these will become a 0. So the number after the number you're rounding to, the digits after the value that you're rounding to always become 0. You've just got to decide whether your number is staying the same or getting bigger. Because it's a 7, we are getting bigger. So my final answer, we write out the beginning of it, it'd be 24,400. If you are not sure on the rounding skill, this is in my numbers place value ebook, as well as the question before. There's questions there about rounding, about partitioning, and negative numbers. Question 9. Here are some diagrams showing parts of a circle. Match each diagram to the name of the dashed line. So this is a specific objective in the Year 6 National Curriculum where you need to understand the parts of a circle. And there is a lesson on this in my geometry ebook. So do check that out if you are unsure on circle properties. So I'm just going to solve this. And you can just have a think about whether you understood this. The circumference is all the way around the outside. It's the dashed bit, yeah? So the name of the dashed line. The one at the top, we've got a line going all the way across the middle. That is the diameter. And going from the centre to the outside, the centre to the circumference, or half of the diameter, is the radius. And for this objective, you simply need to sort of study it and remember it. Like I say, in the SATS ebook for geometry, there is lessons on circles in there. Question 10. Ken thinks of a number. He divides it by 3. The answer is 72. What number was Ken thinking of? So with a question like this, it can be a bit confusing if we're trying to hold all of the information in our mind. So the best thing you can do is just to start jotting down what is said. Now, Ken thinks of a number. We can use a bit of algebra here. We don't know what the number is. You could use an unknown symbol. So you could use a letter. Ken thinks of a number. You could label that as X, or you could just use it as a question mark. Ken thinks of a number. So I'm going to give that as a question mark. He divides it by 3. The answer is 72. I've simply written out what is said as a number sentence. This is actually an algebraic expression because we've got a missing value here. We've got a number that we're not sure of, so we're replacing that number with a symbol. Okay, it could be a letter or just a symbol. So something divided by 3 is 72. Now when you write it like this, hopefully you can see that if you use the inverse, you will be able to figure out what the answer is. So what is the opposite of dividing by 3? We worked backwards. The opposite of dividing by 3 is to multiply by 3. So if we were to work backwards, we can think of our 72 that way. Multiplying by 3 is going to give us our answer. Okay, and we could write it the other way around. 72 times 3 is going to give us our answer. When we write it like that, it looks a lot more obvious what calculation we've got to do. It's just a short multiplication. So 2 times 3 is 6, 7 times 3 is 21. Our answer is 216. If you're not sure, you can take this number and go back. Ken thinks of a number. Is it 216? He divides it by 3. The answer is 72. If you're really unsure if you got the right answer, let's just test it out. So Ken's number divided by 3. 3 into 2 doesn't go. So we carry it. 3 into 21 goes 7, and 3 into 6 goes twice. His answer is 72, and we can see that that matches that, so we can be sure we've got the right answer. Question 11. Write the number that is 1,000 more than 19,039, and then write the number that is 100 less than 19,039. Okay, what might help here is to write the number out. Space it out so you've got space to write down the values. So ones, tens, hundreds, thousands, and 10,000s. Now I'm going to put my separator in there. Write the number that is 1,000 more. So the thousands, the separator tells us how many thousands there are. So we've got 19,000 here and we want 1,000 more. So 19 plus 1 is 20. This is just going to be 1,000 more, we'll make that 20. This will stay exactly the same. Okay, so we've got 20,039. The only bit that should change is the 1,000. Anything after it should stay the same. So for the next one, write the number that is 100 less. So I'm going to take this out. My 100 is here. Now we've got 0, 100, so how would we make it 100 less if we've got no hundreds? Well, we're going to take from our 19,000. If 1,000 is worth 10 hundreds, we're actually going to go back to 18,000 and then 939. Okay, if there's nothing in the hundreds to take from, we take one of our hundreds from our 9,000. So we had 9,000, and then now, if I put a circle around this, we had 9,000, and now I've got 8,900. So my answer here is 18,939. Question 12, draw all the lines of symmetry on this shape. Now for this, you just need to understand what the word symmetry means. And the word symmetry means it's a mirror line. So we need to think about everywhere where we could draw a line, and that would be a mirror line. So for example, down there, the left and the right are the same. If we were to fold that in half there, that would be, it would be the same both sides. Also, there is one here. If I was to fold it top and bottom, that would also be a line of symmetry. That would also sort of match the top and the bottom. It's like a mirror image. Are there any else? Now be very careful, because I've seen some people draw symmetry lines from the corner to the corner like this. But if I was to fold my shape along that line, then it's not going to be equal. You can see like this little bit is quite small, but that bit is quite big. Okay, it wouldn't match up. So there are just two lines of symmetry on this shape, and it's very important that you use a ruler and that you go through the vertices exactly as they are, because if you were, for example, to do sort of this slightly off, it would be incorrect. It needs to go through exactly where you would fold your shape in half. Question 13. 1/5 of a number is 22. What is the number? So this is like a question we did a couple of questions ago, where we are finding a missing number. We can think about expressing this algebraically. 1/5 of a number, so 1/5 of something is 22. Okay, how do we find a fifth of something? To find a fifth of something, we divide by 5. So we could say that that number divided by 5 is 22. Both these sentences are the same thing. A fifth of a number is 22. It's the same as saying that mystery number divided by 5 is 22. Now that we've got that number sentence, we can use the inverse to find out what that mystery number is. And we simply need to think about what the opposite of dividing by 5 is. Well, the opposite is multiplying, isn't it? So we could think about our 22, and if we were going back that way, we would say that we would multiply by 5 to find out what that number is. So it's now just a simple short multiplication. 22 multiplied by 5. 2 by 5 is 10. 2 by 5 is 10 plus your 1, 110. And then you can test it out. A fifth of 110 is 22. So if we had 110 and we divided it by 5, 5 into 1 doesn't go. 5 into 11 goes twice with 1 remainder, and 5 into 10 goes twice. So we can see that that does add up, that matches. So our answer is 110. Remember, if you do all of that, to put the right answer back into your answer box. Question 14, measure angle A. So to measure this, you need to use a protractor. So in the interest of doing this on a computer, I am going to measure this using an online protractor. So I'm just going to switch screen. Okay, so I've got my angle, which is the same as the one in the question, and I'm going to get my protractor. Now, what I need to do is I need to have this part of the protractor where it's coming down from 90 degrees and then going across to 0 and across to 180. I need to have that corner in the corner of the angle that we're measuring. Okay, so that would need to be in this corner. Now that's not in the corner, is it? It's on the outside, so we need it to be, we need to bring this upside down. Now you can also turn your page around, but I'm just going to show you how we do this. Now on a protractor you usually have a measurement on the outside and the inside. So see where this says 180, below it this middle line should say 0. You should have a line here, and if you have got that on there, it's going to be a lot easier to measure because you've got more choices. But what you want to do is you want to get the 0 on your protractor along one of the lines. So you can see that I'm not able to get, if I line it up like that, this line here is on 180. Now a protractor might have a 0 on the inside, and then that way you can read, okay? But this one has it on the outside only, so I'm going to put the 0 on this other line on the left here. It doesn't really matter which way you measure it because the angle is the same size, but you've got to make sure that that's right in the corner. So I can see that is right in the corner. One of the lines is on 0, so that is on 0, and then I'm going to follow this line around until I get to the other line. You can see it reads 130. Now if I had done it like this and I'd read from the inside line 0 here, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, it would say 130 where this 50 is underneath it, okay? Because you're reading, it's 180 take away 50 because the inside is 180 degrees from the other side, okay? One's going left to right, the other's going right to left. But what you want to do is just to make sure that one of your lines is on the 0 and that you go right, follow it round to the other line, and you can see that it's 130. For this question, you were allowed to get 2 millimeters out. So if you'd written 128 or 129 degrees, you'd get a mark. If you'd written 131 or 132 degrees, you would also have got a mark. Question 15. Here are 4 fractions. So we've got 4 cards here with a different fraction on each. Write the fractions in the correct place on the number line. So we have a number line that is between 0 and 1 because these fractions are less than 1. So it's about ordering these fractions. Now, there's lots of different ways you can use clues on this number line, but another way is just to look at the order. Now, one of the rules with fractions is that when they have a different denominator, it's quite hard to compare them. We try to always have the same denominator. However, because these have got the same numerator, we are able to compare them. Now, when fractions have the same denominator, we would look at the numerator, and the size of the numerator tells us the size of the fraction. So, for example, 1/5 is smaller than 3/5, and it's smaller than 4/5 and 5/5. So the numerator 1 is smaller than the numerator 2 and 3 and 4 and 5. However, when the denominator is different and the numerator is the same, it's the opposite way round with the denominator. So here we have all number ones as a numerator. Our denominator is going to be, the biggest denominator is the smallest fraction, and the smallest denominator is the biggest fraction. Okay, so it's the opposite way round. If you think about something cut into 6 slices, or the same thing cut into 2 slices, the one with 6 slices is going to be, one of those slices is going to be smaller than one of the slices that's cut into 2. So that's one way you could do it without even having to think about the parts of the number line. We can literally just write it in order. So you can see that the smallest number has the biggest denominator, and we are just decreasing the denominator. So from 6 to 4 to 3 to 2. That's the simplest way to do it. The other way, you hopefully could see that this way, this one is halfway, and that half of a half is a quarter. Well, you could see that that is a quarter of the way along. If we jumped like this, 3, 3, 3, 3, you can see that that is one of the quarter of the way round. And if we were thinking about it in halves, you can see that and that. That's not very neat, but there's two sections there, that's a half. And then you just have to think about a 6 and a third where they would go. But the easiest way to do this is to think about if the numerator is the same, you can simply just compare the denominator, and the biggest denominator is the smallest number. Question 16. One day last year, the rate of rainfall from 6:30 a.m. until 9 a.m. was 2 millimeters per hour. What was the total rainfall from 6:30 a.m. until 9 a.m.? Okay, so the important bits of information are obviously the time from 6:30 until 9, but also 2 millimeters per hour. Whenever you have a measurement question, just double check in the answer box what it's asking for. So it does want us to stick to millimeters. So just make sure you're aware of that before you start. Now, I would use a number line for this. You don't have to use a number line, but this is what I would do. And I'll just quickly write my times in. So 6:30 until 9. And 2 millimeters per hour. Okay, so we could actually go and plot this now. So we could say, okay, 2 millimeters in an hour, okay, 1 hour. So the time there then would be 7:30. Let's now do another 2 millimeters. 2 millimeters in the hour. That takes us to 8:30. So you can see here now, then we actually have only a space of half an hour. We don't have an hour. So this is 30 minutes. So if it's 2 millimeters an hour, what does that mean for the half an hour? Well, that just means it's the half of that amount, so it's 1 millimeter. Okay, so you can clearly see here, between 6:30 and 7:30 there was 2 millimeters, between 7:30 and 8:30 there was 2 millimeters, then that last half an hour is 1 millimeter. It doesn't matter if you did the 1 millimeter between 6:30 and 7 and then did 2 hours. Either way, it's all going to be the same, but the important bit now is to add all of the amounts up. So we've got 2 millimeters, 2 millimeters and 1 millimeter, and add those up, and that gives you your answer of 5 millimeters. Question 17. The manager of a flower shop orders 4 boxes of red roses. I'm going to start underlining 4 boxes. There are 50 roses in each box. 50 roses in each box. So already I can see 4 boxes, 50 roses in each box. So I already know here, mentally, I'm going to be thinking, okay, so 4 lots of 50 roses, 4 boxes of 50 roses. The manager makes bunches with 6 roses in each bunch. Okay, another bit of important information. I'm just going to put it in a different colour because I know this is going to be a different step. What is the greatest number of bunches that can be made? Okay, in order to answer that third sentence, or to think about the 6 roses in each bunch, we need to know how many roses there are all together first. Okay, so this is 2 steps. It's got 2 marks that tells us that there is at least 2 steps. So the first bit is we need to figure out how many roses do we have all together. We know there's 4 boxes, 50 roses in a box. So the first calculation we're doing is our 50 times 4. Now, you could probably do this mentally, because if you know what 5 times 4 is, then you'll know what 50 times 4 is. But if you want to, for accuracy, just do a short multiplication, then you can just do a short multiplication like this. 5 times 4, sorry, 0 times 4 is 0. Get rid of that. Zero times 4 is 0, 5 times 4 is 20. So 200. So we're dealing with 200 roses. and the manager makes bunches of 6 roses in each bunch. So from that 200, she's using 6 at a time to make a bunch. So this is a division. So we now need to do 200 roses, and if we were to do bunches of 6, that means that we have to divide by 6. So we're going to do a short division. 6 into 2 does not go, so that becomes a 20. 6 into 20 goes 3 times, that has a remainder of 2. 6 into 20 goes 3 times, and there is a remainder of 2. Now, you might have learnt how to divide with fraction, remainder as a fraction or as a decimal, and you can do that here, but it's actually not necessary. Okay, so I could say that the answer to this is 33 remainder 2. I could also say the answer is 33 and 2/6 or 1/3. And I could say the answer is 33.33333, but that doesn't matter. It's 33. I can make 33 full bunches, and the manager can make 33 bunches, and there's going to be 2 roses left over. Can they do anything with those 2 roses? They can't, because the bunches need 6 roses. So we already know the greatest number, doesn't matter about the remainder, the greatest number that can be made is the 33. So this question is one of the objectives in Year 6 where you are interpreting remainders. You're doing division and you are interpreting remainders. All of my lessons on division, long division, short division, interpreting remainders, knowing whether to round up or down, it's all in my calculation ebook. Question 18. A cinema sells tickets at 3 different prices. 1/20th of the tickets are price A, 3/5 of the tickets are price B, the rest of the tickets are price C. What fraction of the tickets are price C? So here we have a fraction question in a word problem. So it's the same skill as when you're doing fractions in your arithmetic paper, but you're having to sort of figure out what calculation you need to do. So we've got 1/20th, we've got 3/5, and then we've got a mystery. But what we do know is that the cinema sells only at those 3 prices. So what we do know is that all of these add up to 1. They total 1 because that's all of it, right? So what we know is 1/20th add 3/5 add ticket price C equals 1. Okay, so we're just writing what we know. What we need to do is find out what C is. Now, you should know that when we're adding fractions, we need our denominator to be the same. So the first thing we're going to have to do is to change these denominators so they are matching. Now, I always look at the smaller denominator and first check whether that will scale up to meet the bigger denominator, and it does. 5 is a factor of 20, 20 is a multiple of 5, so I only need to change one of my fractions. So we're going to write these out again at the bottom, and I'm even going to write out my answer of 1 at the bottom as well. So we know that, let's put it back in a different colour. I'm actually going to zoom in as well. So my 1/20th is going to stay the same. My 3/5 I'm going to change to a fraction out of 20. Just make sure your zeros look neat. It's very hard on a computer. So 3/5 is going to change to a 20th. To make that an equivalent fraction, 3/5 is the same as 12/20ths. If you're not sure, on your equivalent fractions, then you need to do some work on equivalent fractions. It is a year 5, year 6 skill. You can find stuff on equivalent fractions in my number fractions SAPS ebook. So 1/20th plus 12/20ths plus another 20th, we're not sure what that is yet, equals, and then my 1 is 20/20ths, yeah? So a fraction where the denominator and numerator are the same is the same as 1. So if we look at our fraction now, we've got all the same denominators, yeah? So we just need to add the numerators. So if we look at our numerators, we know that it needs to add up to 20/20ths. We've got bear with me. We've got 1 and 12 and something will make 20. Okay, so 1 and 12 make 13 plus something make 20. So that gives us our answer. 1 and 12 plus 7 make 20. We know that the three of them need to add up to 20/20ths, which is the same as 1. We've changed the denominator so they're all 20. And that helps us find the missing fraction. So the missing fraction is 7/20ths. Write the missing number to make this division correct. So it's got in bold division, so it's just reminding us that the calculation is a division. So we've got 15,000 divided by something is 75. Now this involves us understanding the rules with a division number sentence. Now the rules of a division number sentence are that these two numbers can be swapped. Okay, if I show you with a really simple example, if I had 10 divided by 5 is 2, and 10 divided by 2 is 5. Yeah, these two numbers can swap in a division. So it's testing your understanding of that. You try it out of a different number sentence, write a division number sentence, and you'll see that the two numbers, the number you're dividing by, your divisor, will be able to swap with the answer each time, okay? Because 5 and the 2 are the factors and 10 is the multiple. So that's exactly the same with this. So to find your answer, all you need to do is swap those two numbers around. So you just need to think of it as 15,000 divided by 75, and that will give you your answer. Okay, so then we now know it's just going to be a division. So now it is about doing some long division. So you're going to need your bus stop. And then I'm just going to rub that out so I've got space. You're going to need to write out your 75 times table. Now what I always do is make a list. Now if you need help with long division, I have, as well as my SATs ebook, I've also got a long division course, and you'll learn how to do long division in just 5 really easy short sessions. Okay, it's really useful. So I'm not going to spend loads of time on demonstrating this. I'm going to fill in my 10 multiples of 75, and then I'm going to use those to do my division. So 75 into 1 doesn't go, 75 into 15 doesn't go, so I've now got 150. 75 into 150 I can see goes twice. I prove it underneath, I subtract it. Sorry, I've done that wrong. I prove it underneath. 75 times 2 is 150. I prove it. 75 times 2 is 150. Take it away. That is 0. Bring the next one down. 75 into 0 doesn't go. Prove it. 75 times 0 is 0. Take that away. It's 0. Bring the next one down. Is 0. 75 into 0 goes 0 times. So there we go. Another way, so the answer is 200. Another way you might have looked at it, if I just delete this, is 75 times something equals 15,000. And then it's just about recognizing some of the numbers in here, thinking about place value and recognizing what a pattern. I would be making a link between, I know that 75 goes in twice to 150. Okay, so I can see that 150 there, and then I can see that this is 100 times bigger than 150 because there are 2 extra zeros, so that's 2 placeholders. It means it's 100 times bigger, therefore the 2 will be 100 times bigger. You see that there, the link? And that will make the 15,000, it will be 100 times bigger. Okay, so it's sometimes just looking for patterns, looking for known facts, and that is one of the objectives in Year 6, using known facts. So always look for a known fact. If you can see any links, if you were to make this number smaller, can you link it to this number, or using the inverse, or using your understanding of how divisions work. Write the 2 digits to make this long multiplication correct. So this is really testing your understanding of long multiplication. And for something like this, I would work your way through even the bits that are filled out. So try not to get intimidated by all the numbers that are there, and just work your way through. So I'm going to use a green pen so it stands out. So I would be starting here. 5 times 3 is 15. So the 5 is there. I'd put my 1 there, as you would. Sometimes your school might teach you to put your 1 above. It doesn't really matter how you do it, as long as you stick to it consistently. You need to have the 15 there. So now 3 times 3 is 9, plus that 1 is 10. So that 0 is correct, but we need to put a 1 there or above if that's what you would do. 2 times 3 is 6, plus the 1 is 7. So that is working, isn't it? We don't need to carry anything. Now something times 3 is 9. Okay, something times 3 is 9. Well, we know that 3 times 3 is 9. Okay, so that's our first bit. Now, when we go to the next line, this bit is just our placeholder, isn't it? Okay, so for this next bit, I'm going to use a different colour just for demonstration purposes. So 5 times something makes 5. Now, you might be tempted to go, oh, it's just 1. 5 times 1 makes 5. Which it does, but now let's go to the next number. So sorry, the 0 is the placeholder. We then go to 5 times 1. 3 times 1 is 3, so that doesn't work, does it? That has not worked for that 7, so it's not a 1. But with the 5 times table, 5 times 1 is 5, 5 times 2 is 10, that wouldn't work. 5 times 3 is 15, so that might work. 5 times 3 is 15, so we'd have the 5 and then we'd have a 1. 5, then we go 3 times 3 is 9, plus the 1, that doesn't work, does it? Okay, so it's not a 3. So what you could do is to think about all the different multiples of 5 that end in a 5. So we've got 5, 10, 15, 25, 35 and 45. It's not going to be anything higher than that because if I do another colour now, that's 1, 5. Oh, that hasn't worked. That's 1, 5. That's 3. That's 5. That's 7. That's 9. You can't have a digit bigger than 9 in there, can you? Yeah, so it's going to be only one of those. Now that doesn't work, that doesn't work. So what if it was 5 times 5? And you might want to just do it in your head. So 5 times 5 is 25. That would have a 2 carried over, like that. 3 times 5 is 15, plus the 2 is 17. So that would work. So let's give that one a go. So if we put 5 in here. So 5 times 5 is 25. I've carried my 2. 3 times 5 is 15, plus the 2 is 17, so we carry the 1. 2 times 5 is 10, plus your 1 is 11, so that would work, need to carry a 1. And then 3 times 5 is 15, plus the 1 is 16, so that does work. Okay, So it's just a bit of trial and error with this and testing out. You don't need to worry about adding it up because it's not asking us to see if it's correct. All the answers are there. It's just finding which digits would fit in those boxes to make that correct. And we've tested it, and that all works. If you really want to, and you want to at the end test it, you could just write it out again. But I wouldn't do that at the beginning. I would maybe finish your test and then come back to that. If you put a star to remind you to come back and then just test it out, you will get these answers. Question 21. The height of the tallest person in history is 8 feet 11 inches. Here we have a conversion table. 1 foot is equal to 30 centimetres and 1 inch is equal to 2.5 centimetres. If you're not sure on units of measurement and conversion, this is an objective in the Year 6 curriculum, and I do have lessons on this in my measurement SATs ebooks, all sorts of stuff on units of measurement, how they fit into one another and how you convert as well. So we're given a conversion table, and it wants us to use this conversion table to calculate the height of the tallest person in centimetres. So we are changing our feet and inches. And in fact, what I'm going to do is just do these in different colours. So we're changing our feet and inches into centimetres. So if I highlight the feet differently to the inches, just so you can see what I'm doing. Okay, and I'm going to write 8 next to the feet, 1 foot, 8 feet, and I'm going to write 11 next to the inches. Okay, this is telling us what 1 foot and 1 inch is. That's very important because if 1 is 30, what we do is we think about how does number 1, what do we multiply 1 by to get to 30? We're multiplying it by 30, aren't we? So we're going to multiply this by 30 as well. Okay, 1 times 30 makes 30 centimetres. 8 times 30 is going to give us our centimetres. And then here, 1 times what makes 2.5. So there's number 1. If I write the number 1, it's in a word, so sometimes we don't see the link. 1 times what makes 2.5. 1 times 2.5 makes 2.5. So that's our scale factor. So we're going to do so this is our conversion here. This is telling us how we convert it. We have to multiply by these numbers. So to do 8 times 30, if you know that 8 times 3 is 24, you know that 8 times 30 or 8 times 3 tens is 24 tens, which is 240. Can you see there's just an extra 10 times bigger, so this will be 10 times bigger. So we know that it's 240, 8 feet is 240 centimetres. Now 1 times 2.5 makes, 1 inch times 2.5 makes 2.5 centimetres. So we're going to do 11 times 2.5. Now how I would do this is I would do 11 times 2 and 11 times a half. So 11 times 2 is 22. And 11 times a half, you could think of it as 11 times 5. If 11 times 5 is 55, then can you see that 0.5 is 10 times smaller than 5? So my answer is going to be 10 times smaller. It's going to be 5.5. Another way to do 11 times a half, even though I've written 0.5, if you think of it as a half, I'll write it over to the side here, 11 times a half is exactly the same as a half of 11. So we're just halving 11. Half of 10 is 5, half of 1 is 0.5, so it's 5.5. So we've got 22 and we've got 5.5. You need to add these two numbers together and that gives us 27.5 centimetres. So we've now got that our 8 feet is 240 centimetres and our 11 inches is 27.5 centimetres, your final thing is to add these up. So we've got 240 and we've got 27.5. Make sure you line these up. Now the 240 has no decimals, but I would give it a decimal, just put a 0.0, so that when you're adding you don't make any mistakes. I always make sure that decimal numbers have the same amount of decimal places, even if that means giving it a 0.0. I put a decimal point in my answer before I even start, so I'm not going to make a mistake. I'm just going to put the answer in a different colour. So we're adding 0 plus 5 is 5, 0 plus 7 is 7, 4 plus 2 is 6, and 2 plus nothing is 2. So we found our 8 feet, we found our 11 inches, we've added it together, and our final answer is 267.5 centimetres. Question 22. Here is a regular hexagon. The area of the large shaded triangle is double the area of the small shaded triangle. So here's the large shaded and here's the small shaded, and this is double what this is. Some important things here are that it is a regular, get my highlighter, it is a regular hexagon. Okay, so you need to know the difference between regular and irregular shapes. It also helps to know how many sides a hexagon has got. You can find all this information in my geometry ebook. So it's asking us what fraction of the whole hexagon is the shaded area. Okay, let's look at what we know. So we know that a hexagon has 6 sides, and being a regular hexagon means that all the sides and angles are the same. Now, if I just do this, I can show you how this shape can be split like this into 6 identical triangles. Okay, every triangle is identical. This shaded triangle is the same as each of these other triangles. This one at the top, if I shaded both sides, it's the same. Yeah, all these green sections are the same size. What that tells us is that this part of the triangle, this part of the hexagon, this large shaded triangle, is exactly 1/6 of the pentagon. Okay, because it's one portion out of 6 portions. If I was to divide my whole pentagon up, I can divide it into 6. My whole hexagon up, sorry, I can divide it into 6 equal sections because it's a hexagon. It's got 6 sides and it's regular, so I know that each section is the same. Now, what is the area of this one up top? Because this one up top is not the whole triangle, it's half of the triangle. So we need to think about what half of a 6th is. Okay, if you're not sure what half of a 6 is, you could do it as a multiplication. Half of a 6 is the same as saying half times 6. Okay, and when we multiply fractions, we do not need the denominators to be the same. We multiply the top, 1 times 1, and we multiply the bottom, 2 times 6. Oops. So a 1/12 is half of 1/6. So this section is worth a 12th. Okay, so all we've done is we found the fractions of each portion. Now we need to know the fraction of the whole hexagon of all the shaded areas. So we now need to add these up. So we need to add 1/6 and 1/12. Now when we're adding, we do need our denominators to be the same. Okay, so we're going to change at least one of our fractions so that we have equivalent fractions. Now I always check to see if my smaller denominator, 6, can scale up to meet my larger denominator, and it can. 6 does fit into 12, so I can just change my 1/6. So my 1/6, if I was to represent that as 12s, my 1/6 is equivalent to 2. So I'm just going to make this a bit neater, and I'm just going to write this to the side. So 1/6 is the same as 2/12. That's that. And my 1/12 can stay the same. As I now have matching denominators, I can just add up. I know my denominator is going to be 12, and 2 plus 1 makes 3. So it's 3/12. My answer is 3/12. Now I can further prove that. So earlier on, I divided it all up into 6 sections. If we were to take it one step further and also divide each triangle in half, like that. So every triangle in half. You will now see that there are, if I start at this shaded section here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections, and 3 of those sections, so 1, 2, and 3 of those sections are shaded. So we have 3/12. Question 23. A small box contains 650 grams of cereal. A large box contains 20% more cereal. One portion of cereal is 40 grams. How many full portions are in a large box? We've got lots of information here, and it's got 2 marks. This tells us that there are more than one step. The important thing is to not try and think right to the end and get intimidated. The important thing is to take one bit of information at a time. So a small box is 650 grams, and I would be tempted just to label it. It's already labelled on there, but I would just label it anyway. 650, and I'd write my G grams. And take note, the answer is asking us for portions, not grams, okay? So make sure you look at that. A large box contains 20% more cereal. So I want to label this, so I can do that just with that information. It's got 20% more cereal. So let's calculate how many grams is in that box. So 20% more means we're going to have to find 20% of 650 and add it to 650. So 20% of 650, I would find 10%. I am going to zoom in. So 10% of 650 is 65 grams, okay, because we just divide by 10. So another 10% is 65 grams. So those two combined, if you added 65 and 65, so you can do a written addition or add it in your head, I'm just going to write it down, is 130 grams. So 20% is 650. We now need to, 20% is 130. We now need to add that to 650. So 650 add 130. You might be able to do this in your head. Is 0.87. So 780 grams. So let's label up our cereal now. So our big box is 780 grams. Okay, so we've just found this bit of information, and that could be enough just to get you one point. Next bit, one portion of cereal is 40 grams. How many full portions are in a large box? So we need to know, out of our box of 780, how many portions of 40 grams can come out of that box. So it's a sharing, it's a division, isn't it? So we are going to do some division. We're going to do a long division. So I haven't got a lot of space on here, so I'm going to rub this out. Obviously, in your stats paper, and actually I won't rub it out, I'll show you. This is the whole page. You've got loads of space down here as well. This is the actual page. Let me zoom out and show you. This is actually your part of your page. Look, you can write anywhere on your page. So I'm actually just going to write underneath here. So I'm going to zoom back in. We're doing 780 divided by 40. And I'm going to use the bottom of the page here. This is what you can do in your test. You do not get marked down for writing outside the box. It's not like in school if you've got to be really neat and stuff like that. So we are doing 780 divided by 40. So you might want to write out your 40 times tables. I'm actually not going to write them out. I would list your 40 times tables, but I'm just going to solve it as we go. So 40 I know doesn't go into 7. Then I've got 78. I know that 40 into 78 is only going to go once because 2 40s are 80. So I'm going to prove that. 40 times 1 is 40, and I'm going to subtract that from the 78. 8 take away nothing is 8, and 7 take away 4 is 3. And then we go bring that down, and we've now got 380. How many 40s fit into 380? Now I know this because I am looking at 40 as a 4 and my 380 as a 38. So I'm using known facts. I know, and actually I'll just quickly jot down the 40 times table because I will show you how it does actually really help. Okay, so 380, if I go down my list here, 360 is the highest I can go. 400 is too much, so it's 9. So I would be saying it fits in 9 times. Then I prove it. 9 times 40 is 360, and I write that underneath. And then I subtract that, and that is going to be 20, and that's my remainder. Okay, so it's 19, remainder 20. In this question, you don't need to worry about representing your remainder as a fraction or a decimal because the question doesn't ask for that. The question wants to know how many full portions. So this is saying I can make 19 portions of 40 grams, and then I'm going to have 20 grams left over. So this remainder is grams, yeah? So what can I do with that 20 grams? I mean, you could have a smaller portion, but the question is asking us specifically is how many full portions are there? You can see it's in bold. How many full portions are in the large box? So full portions is 19. Just quickly show you that on the screen. Our answer was 19 with a remainder of 20. We can make 19 full portions. It doesn't ask us, it doesn't have a part B where it says what's left over. It just wants to know how many full portions there are. Just to make sure that's very clear. So it's just our full answer, ignoring the remainder. Paper 2, question 24. 1,200 pupils were asked this question. How important is it to have a break when using a screen? This chart shows the results. And you can see we have a pie chart. The pie chart is sectioned off into 3 parts. One part of the pie chart is too small to fit the words on, so the words are just off the pie chart, but you can see the line is indicating that that is the section it refers to. So we've got a very important, a quite important, and a not important. Now we have the percentages for not important and quite important, but we do not have the percentages for very important. So we've got 12% here, 41% here, and nothing here. And the question is asking us how many pupils answered very important. Important to note as well that it's how many pupils and not the percentage, because on our chart we've got numbers in percentage, which is not the same as how many pupils, okay? When we're thinking about how many pupils, we need to refer back to this information, 1,200. Now, the first thing to note is that a pie chart represents all of the data. Okay, so this pie chart represents 1,200 pupils. So the pie chart will also represent 100%. So the first thing we can do is we can subtract the not important and quite important from our 100% to figure out what percentage very important is. Now you could either do 100, subtract 12, subtract 41, or you could do 12 plus 41, which I'm going to do. 12 and 41 is 53. And I would then do 100%, take away 53%, which equals 47%. So I know that my very important is 47%. Okay, so all we've done is we've found the missing percentage. That's still not our answer. The question is asking how many pupils. So what we now know is that we have 47% of our pupils that were questioned chose very important. And we know there were 1,200 pupils. So we are finding 47% of 1,200 pupils. Okay, so if you are not sure how to calculate percentages or indeed how to analyse and read pie charts, then there are ebooks on pie charts. That's the statistic ebook, covers all things to do with pie charts. And you can also find stuff on percentages in my ratio ebook. So there are things to do with percentages in the fractions book, but to actually calculate percentages of numbers is in the ratio ebook. So I'm just going to go through a quick way to solve this now, and I'm going to do 40% of 1200 plus 7% of 1200. So I'm actually going to find 50% of 1200 and then subtract 3% of 1200. So I'm just going to do it in a different colour. So I know that 50% of 1,200 is 600. And I know that 1% is 12. So 3% is therefore 36. And I'm just going to do 600 subtract 36 because that is the same as 50 subtract 3 is 47%. So 600 subtract 36 will give me my 47%. And you can write this in a column subtraction, or you can just do this mentally. So 564 pupils. There are different ways of calculating percentages. That is certainly not the only way. And you might have done 40% plus 7%. You might have done 1200 times 47 and then divide your answer by 100. There are lots of different ways to calculate percentages. But the important bit is that you have realised that you find the missing percentages by subtracting the two sections from 100%, and then you use that to find that percentage of the amount of people that were in the survey. Question 25. There are 25 sheets of paper in a small pack. There are 500 sheets in a large pack. How many small packs make one large pack? That's the first part of the question. Then there is another part of the question, but we're just going to look at part one to begin with. It's a 1 mark question, so it should just be one calculation. How many, so we've got 25 sheets and 500 sheets. How many of the smaller sheet pack make a large pack? So it's a sharing question. So it's a 500 divided by 25. So 500, the number sentence is 500 divided by 25. Now for this, you could do a long division, or you might look for a known fact and you might spot the link between 50 and 25. Now I know that 50 divided by 25 is 2. Therefore, if my 500 is 10 times bigger, 500 is 10 times bigger divided by 25. As I've got more to share, I'm going to have a bigger answer, is 20. Okay, or you might do a long division, you'll get the same answer. I've demonstrated in previous questions how to do long division, so I'm not going to go over that again. I would be looking for a known fact here. So my answer is it fits in 20 times. If you want to be double sure, just do 25 times 20 and you'll see that that will equal 500, just so that you can feel more confident that you're accurate. So let's move down to the second part of the question. The mass of the paper in the large pack is 2.4 kilograms. What is the mass of one sheet of paper in grams? Okay, so we've got a few different things to take note of here. One is that we're given the mass in kilograms, but they want the answer in grams. Okay, so we need to pay attention to that. Answer is in grams. the mass of the paper in the large pack is 2.4 kilograms. So the 500 sheets, because it's got 500 sheets in the large pack, is 2.4 grams. Now what I would 2.4 kilograms. Now what I would do, as the answer is in grams, I would straight away be changing this 2.4 kilograms to grams. Okay, so 2 kilograms is 2,000, so it's 2,400 grams. If you're unsure how to convert kilograms to grams and vice versa, then check out my measurement ebook, and that's got all the stuff on converting units of measurement. So what I would now write, I'm going to zoom in, is that 500 sheets of paper equals 2,400 grams. So if we know that 500 sheets of paper are 2,400 grams, it's asking us what one sheet of paper is. What is one sheet of paper? So what we need to do is we need to divide, we need to share that 2,400 by that 500, don't we? So we need to do a division. 2,400 divided by 500. So let's get to it. And I'm just going to show you a shortcut after this, but let's just do it this way to begin with. So 500 into 2,400 in a bus stop method is not going to be very efficient because 500 doesn't go into 2, it doesn't go into 24 or 240, and you're just going to have to figure out how many times 500 fits into 2,400. So you could count up in 500s. Or what I would do is to make each number smaller. So 2,000, let me write it over here, 2,400 divided by 500 is the same as 24 divided by 5. What we've done is we've made this number 100 times smaller and this number 100 times smaller. It will be the same answer, and I'll show you why. So we're going to change this to 24 divided by 5. So 5 into 2 doesn't go. 5 into 24 goes 4 times with a remainder of 4. Now we're going to need to convert our remainder to a decimal. So you could, one way you could do it is it's 4 remainder, 4 times 5 is 24, remainder 4. Your remainder the remainder is always the numerator, and then your divisor, bear with me, my highlighter is not wanting to play ball today. So this divisor becomes your denominator. So it's 4 and 4/5. Or to change it to a decimal, because it's, I think, going to want a decimal rather than, I mean, you might know what 4/5 is as a decimal. The other way is you put a decimal next to your 4 and make that a 0, and you take your remainder there. So 5 times 4 is 20, so there is a remainder of 4. We put it like that. And 5 into 40 now is 8, so it goes like that. If you don't know how to divide using decimals, this is in my calculation ebook. It is a skill that you need to do. It's relatively simple. It's exactly like the other division. You're just putting your decimal point down and then adding a 0.0 and then carrying your remainder on that way. So each sheet of paper is 4.8. Now, if you are really worried that that's not the right answer, make sure that you have your decimal very clear. It's not very neat when I'm writing it on a computer. 4.8. If you really want to make sure, then you can simply do 500 times 4.8, and just see if that works out as being 2,400. Paper 2, question 26. This formula is used to estimate the mass in kilograms of young children. Mass equals 2 times, and in brackets, age in years plus 5. So we have a formula here. This is an algebraic formula that we are expected to use to apply to find our answer. So I'm just going to highlight this is our formula. The mass of Megan's brother is 16 kilograms. Use the formula to estimate his age. Okay, this is in bold. Age is in bold, so it's making sure that we know which part of the formula we are looking for. Is this part. Second part is Stefan's sister is 4 years of age. Use the formula to estimate her mass. So we're going to stick with the first part of the question first. What this question is asking you to do is to use the formula, and what we're looking for is how well you understand the different parts of the formula. Okay, so let's look at the formula. The mass is the same, which the mass at the top it says in kilograms. So the answer in kilograms is the same as the age in years add 5 doubled, okay, because it's 2 times and then in brackets the age in years plus 5. So what we're going to do is we're going to start to plot in the information that we know. So we know the mass of Megan's brother is 16 kilograms. So we can say that 16 is the same as 2 lots of the age plus 5. Okay, so we can start to break this down now. If 16 is, so we don't know what the age is in ages, so we can't add 5 yet, but we can work a bit backwards. So 16 is the same as 2 times something. We know that 16 is 2 times 8, don't we? So if I was to put in a different colour on top, we know that that bracket has got to equal 8 because 16 is the same as 2 times 8, right? So if we know that the age, so if I wrote that out again, the age, the mystery age plus 5, mystery age plus 5 is the same as 8. Well, that helps us a lot, doesn't it? What plus 5 makes 8? Well, the answer is 3. Okay, so now we can just put all that back into the formula to double check. The mass is 2 times the age in years plus 5. So if Megan's brother is 3, we would say 3 plus 5 is 8. Times that by 2, it's 16. And yes, that works. Okay, so we just subbing into the formula the bits we know and then kind of working backwards and forwards so until we find that missing value. Okay, so the next bit is we know what Stefan's how old Stefan's sister is. We've got the age here, okay, and we need to find out what the mass is. So for this one, we would say the mass is equal to 2 times, and then we know what her age is here. It's 4, so instead of writing age, we can put 4 plus, so put 2 times 4 plus 5, okay, because we know the formula says plus 5. Now we can do the bit in brackets. 4 plus 5 is 9. So that means we're doing the mass is the same as 2 times 9. We know what 2 times 9 is. 2 times 9 is 18. So Stefan's sister is 18 kilograms. Now let's just double check that if we wrote it out. So 18 kilograms, we're saying, is the same as 2 times, and then we are saying 4 years old plus 5. So 2 times 4 plus 5, 4 plus 5 is 9, times 2 is 18, and that is correct. If you're looking for some effective revision to help you with your maths SATs, then check out the Pocket Private Tutor Shop. I have SATs ebooks and I have revision courses. The SATs ebooks cover every single thing from the Year 6 national curriculum, so you can be sure that nothing will appear in the paper that you haven't learned. Each ebook comes with a video which you can watch on a laptop, on a tablet, on your phone. You can even cast it to your smart TV if you want to watch it big. I have worksheets to help you practice the skill, and included are past SATs question examples. That means when you're learning a new math skill, I also include how that has looked in an actual SATs paper before. I also have some revision courses, I have practice arithmetic tests, I have loads of stuff that's going to help you to absolutely smash your SATs. So check out the Pocket Private Tutor Shop and download the course that's going to help you now.